Good morning, students. So we are discussing the chapter that is ammonia, and in ammonia we are discussing now its burning of ammonia in the presence of oxygen. So ammonia always burns in the presence of oxygen with a yellowish green flame. Whenever there is a presence of yellowish green flame, we detect that the gas present is ammonia. Certain reactions is that that is burning with oxygen, production of N2 plus 6 water molecules are there. When ammonia burn in the presence of oxygen, production of nitrogen dioxide gas along with some water molecules. As to need to balance reaction, 4 ammonia molecules are required, 3 oxygen molecules are required, 2 nitrogen molecules are formed, and 6 water molecules are formed along with this thing, right? Then what is the procedure to proceed for the ammonia? He said that a white, this side, a white glass tube is fitted with cork. The cork is present here just to control the inlet of two pipes only. One which reaches, the two pipes are there. One which is reaches just near the top one, right? And the second which is little shorter than this first one pipe, okay? And then ammonia gas is passed in the longer tube. That the longer tube, the dry ammonia gas is passed through this longer tube, and oxygen gas is passed from this shorter tube, right? And this longer tube is lightened up with the help of your matchbox. That with the help of your matchbox it is lighten up. आप इसको lighten up करेंगे. And finally what you observe that ammonia burns with a yellowish green flame. That if ammonia burns with a yellowish green flame, and it shows that ammonia containing nitrogen and hydrogen, because ammonia gas burns with that yellowish green flame. Along with that, some water molecules are also present there. That the water molecules are also present there. So it is showing that it contains the nitrogen as well as your hydrogen, because it gives water molecules also. And you know what, the reaction between this ammonia and oxygen is a highly exothermic reaction and a dangerous reaction too, because it is due to the high exothermic, the large amount of heat is produced through this reaction. So this reaction can be explosive in nature, that it can be blast, that this slide or this beaker can be blast because of the explosive nature or because of the heat produced by this reaction. So this is all about what happened to the ammonia when it is burned in the presence of the oxygen. The second is catalytic oxidation of ammonia. So in this catalytic oxidation of ammonia, that in the presence of the platinum at 800 degrees Celsius, ammonia reacts with oxygen to give nitric oxide and water vapors. As you see in this experimental setup, that from this side we are setting up the dry oxygen, from this side we are sending the dry ammonia, and this platinum catalyst is placed in this tube, and in this heating tube, that the heating tube is present there, the combustion tube is there. In this combustion tube, some heat is provided to this platinum catalyst, and ammonia gas is passed through it. So this catalyst provides surface of ammonia and oxygen to react along with each other, and formation of some water vapors occur, because whenever the reaction is between this ammonia molecule and oxygen and within the presence of platinum the catalyst, and at 800 degrees Celsius, formation of water vapors, formation of NO, that is your nitrogen oxide, as well as your heat is produced. That because this is a very highly exothermic reaction. We know this thing, that the reaction between ammonia and oxygen is a very highly exothermic reaction. So this heat is produced, and then further this heat, after this first reaction, that NO is going into this round bottom flask, and from inside this round bottom flask, that NO again reacting with the oxygen molecule, and formation of nitrogen dioxide, that is our nitric oxide, will occur. Finally, the NO is reacting with our oxygen molecule, and formation of oxide, that is the brown color gas, which we observe that a reddish brown vapors of NO2 are seen in the flask. That reddish brown vapors we observe in the flask by the oxidation of NO, that is your nitrogen oxide with the oxygen, and that nitric oxide is again reacting with oxygen, and the formation of nitrogen dioxide will occur. Okay, and the second observation is platinum continues to glow even after the heating stops. Why? Because this reaction is evaluating high amount of heat, or we can say this is your exothermic reaction, that the reaction is very highly exothermic, and the oxidation of ammonia makes this platinum glow even after the heat is stopped from the outside. Okay, so this is all about the catalytic oxidation of ammonia. Now the next topic is reduction of metallic oxides, that how the reduction of metallic oxide will occur. Here the reduction of metallic oxide, that ammonia reduces metal oxides to give the metal, water and the nitrogen gas, right? And the procedure is just to follow that the pass ammonia gas over the heated metallic oxide in a hard glass tube. Just take a hard glass tube and pass out the gas on the metal oxides. Okay, that is the procedure for that. The reaction is ammonia. Suppose we have copper oxide, that is black solid in color, and converted it into a metal, water and nitrogen, and that copper containing a color of reddish brown solid. The color of the copper is reddish brown solid. Its observation is that black copper oxide changes to, although this word written here is very wrong word, as many of you have made this mistake, that the changes word you can use. No, on the basis of this word changes, you need to use the word that is reduce. That this CuO reduced to reddish brown copper. This reddish brown copper will form because the reduction process is the removal of oxygen atom. So that we are doing here, that the removal of oxygen will lead to you the proper pure metal there. And same with the lead oxide also. On reacting with ammonia, they provide lead as well as water as well as nitrogen gas. Lead oxide is a yellow color substance, dark yellow color substance, okay, that haldi color substance, and it is converted into a grayish substance. The grayish metal will come out. When the grayish metal will come out, it simply means that its oxidation completed. That's our observation. That are the observation that we made. Let's move on to the next part, that is the reduction of chlorine to hydrogen chloride. This is the reduction of chlorine to hydrogen chloride. So it's said that when chlorine reacts with ammonia, it reduces to HCl. The reduction to HCl will occur, which further combines with either with the excess of ammonia, either it is combining with the excess of chlorine molecule. So when that HCl is combining with the excess of this ammonia, then there is a formation of ammonium chloride, that is NH4Cl. So combining both the reactions, we have 8 ammonia molecules with 3 chlorine molecules, then formation of 1 nitrogen plus 6 ammonium chloride molecules, right? Because that HCl is used up here, so we are not showing the HCl in this product side part because HCl is already used up here. So we see this thing, that this ammonia is present in large excess there, and this observation will lead to us that the yellowish green color of the chlorine, due to this chlorine we observed a yellowish green color. Some yellowish green color are there, and that yellowish green color will disappear on the reaction with chlorine with ammonia, and white fumes of ammonium chloride are formed. We all know this thing, that the ammonium chloride give you some white fumes. So the white fumes of ammonium chloride are formed, and this yellowish green color will be disappear. That color will disappear from this side. Okay. Now the second reaction is when the chlorine is in excess. When the chlorine is in excess, then the products formed are hydrogen chloride and a yellow colored highly explosive liquid, that is nitrogen trichloride. This is a yellow colored highly explosive liquid, that is a yellow in color plus highly explosive liquid, that is your nitrogen trichloride will form. That nitrogen trichloride is present there. Okay, now this reaction shows that both of the reactions will show you that this the compound that is containing your, एक 1 minute, okay, this what the reaction shows that chlorine has greater affinity for hydrogen, because we found that this chlorine is present with HCl, right? So it must have a greater affinity for hydrogen. And secondly, ammonia, that is NH3, is a reducing agent. That is a reducing agent because it itself get reduced. An agent with itself get reduced, and that is a reducing agent जो दूसरे का क्या कराने वाला है, reduction करवाने वाला है. So ammonia is a reducing agent. These reactions show you all such things. Okay, now moving on to the next part. Now next part is, what is the reaction of aqueous solution of ammonia with some acids as well as with some metallic salt solutions? What are their reactions with some acids and as well as with some aqueous solutions of with the metallic solutions? Chalo, let's take the examples of first the reactions. Total this we just need to learn the reactions only. That first is the reaction with some acids of that aqueous ammonia. So first we need to prepare the aqueous ammonia, that is NH3 plus one water molecule is there. There is a formation of ammonium hydroxide. Its name is ammonium hydroxide and its formula is NH4OH, that is ammonium hydroxide formed. Now this ammonium hydroxide, on reacting with HCl acid, there is a formation of ammonium chloride, that you know, and one water molecule is removed out. Again same, the next reaction is ammonium hydroxide is reacting with HNO3, that is your nitric acid. Then there is a formation of ammonium nitrate along with one water molecule releases out. Same when ammonium hydroxide is reacting with another sulfuric acid, that is the another acid which is sulfuric acid, then there is a formation of ammonium sulphate SO4 plus two water molecules are released down. Just to balance the reaction, we need to make it two molecules of ammonium hydroxides. Okay, so these are the reactions when ammonium hydroxides are reacting with the water molecules. Then always this ammonium hydroxide on reacting with any of the acid, that is the acid, then there is a formation of salt plus water. Always there is a formation of salt plus water will occur. This is the reaction with the aqueous of ammonia with some of the acids. Only such things are the part of your syllabus. Rest the things are not in the syllabus, so do not do them. Okay, now the next thing is that any of the metal salt solution, we have any of the metal salt plus then we have your ammonium hydroxide. There is a formation of ammonium salt plus metallic hydroxides. Okay, then the formation of ammonium salt, that is the salt here, plus metallic hydroxide, that the metal hydroxide PPTs are also formed along with this thing. So few examples are the part of syllabus. That first is ferrous sulfate. That ferrous sulfate is reacting with ammonium hydroxide, formation of a salt of, that is ammonium whole twice, that is SO4. Okay, then we need to take two ammonium hydroxide molecules, and finally next is the formation of metal hydroxide. That metal hydroxides PPTs are formed, and these PPTs, that the metal hydroxide PPTs which are forming here, they are dirty green in color. The metal hydroxide PPTs are dirty green in color. Remember this thing, dirty green in color, and they are insoluble in the excess of ammonium hydroxide. They are insoluble in excess of ammonium hydroxide. Now the first one is this FeSO4. The second one is your iron trichloride plus along with 3 ammonium hydroxide molecules, formation of further 1 ammonium chloride, that is the NH4Cl, plus along with this thing FeOH thrice is pipetted down, and it is a reddish brown color PPTs are formed here. The color of the PPTs are reddish brown in color. This is a reddish brown color PPT are formed, and all although they are also insoluble in the excess of ammonium hydroxide. Now moving on to its third part, that is the third reaction part, which is given as lead nitrate PbNO3 whole twice plus, along with two ammonium hydroxide molecules, there is a formation of ammonium nitrate. Two molecules of ammonium nitrate are formed along with a hydroxides of lead, that is PbOH twice, that will be put down, and it's a white color substance. Again, it's also insoluble in the excess of your ammonium hydroxides, that the white color substance is formed here. The first reaction is with ferrous sulfate along with this ammonium hydroxide. Formation of ammonium sulfate will occur with this FeOH twice, that is the ferrous hydroxide is there. The dirty green PPT are formed, insoluble in the excess of ammonium hydroxide. Second reaction is with ferric chloride, that is with along with ammonium hydroxide. Ammonium chloride is formed with ferric hydroxides are there. Okay, that is a reddish brown color PPTs are formed which are insoluble in the excess of ammonium hydroxide. Next reaction is with the lead nitrate with ammonium hydroxide. Ammonium nitrate will form along with lead hydroxides are formed, that are white color PPTs formed, and they are insoluble in the excess of your ammonium hydroxide. They are also insoluble in the excess of ammonium hydroxides. Now the next reaction is with zinc nitrate. These are the last two reactions of this chapter. The next reaction is zinc nitrate, same with ammonium hydroxide. After the reaction with ammonium hydroxide, two molecules of ammonium nitrate are formed. Either it is zinc nitrate or either it is lead nitrate. Formation of always the ammonium nitrate along with zinc hydroxide will occur, and that zinc hydroxide are the white gelatinous PPTs, that the white gelatinous PPT, jelly kind PPTs are formed, and they are soluble in the excess of your, they are soluble whenever excess of ammonium hydroxide is present. Okay, now the last and the last reaction is copper sulfate. That copper sulfate is reacting with ammonium hydroxide. Formation of ammonium sulfate will occur plus CuOH twice, that is copper hydroxide has formed. That copper hydroxides are your pale blue color, that copper hydroxides are pale blue color substance, and that pale blue color PPTs are soluble in the excess of your ammonium hydroxide. So as you see from these reactions, so two are soluble, two hydroxides are soluble. First is the zinc hydroxide, second one is the copper hydroxide only, which are soluble in the excess of ammonium hydroxide, that is white gelatinous PPTs, and that is the pale blue color PPTs are formed. But if we talk about the ferrous hydroxide or the ferric hydroxide, that is your FeOH whole thrice and FeOH twice, and that is lead hydroxide. They remain insoluble in the excess of ammonia. They are insoluble in the excess of ammonia. And secondly, the first one, that is the ferrous hydroxide, it is from a dirty green color PPT, that is ferric hydroxide reddish brown, and lead nitrate is the white color substance, that the white color PPTs are there. So this is all about done with this chapter, that is our ammonia. So that's the part completed here with this chapter ammonia. Do read this chapter from your book, do practice its questions from your book, and just see you in the next video in the next lecture with the next chapter. Thank you. Stay then safe and happy at your home.